Good day, everybody. Welcome to our continuing discussion on Euclidean constructions. You remember, our goal is to only use a compass, a circle drawing device, and a straight edge, a straight line drawing device to construct a variety of things. Now, we laid the groundwork last time where we ultimately want to draw some polygons and some circles. But in order to make that process a little bit easier, we have some intermediate constructions that we highlighted first. By far, the most important one of these is the perpendicular bisector. So let's just review that before we move on. Perpendicular bisector means I have a line segment. Let's suppose it's over there. It doesn't have to be horizontal. I want to draw a line perpendicular to this, so making a 90-degree angle square to this line. That cuts this line in half perfectly. I can't eyeball this. It's even worse when it's slanted. There's no way. And I can only use a compass and a straight edge. I can only draw circles and straight lines. How do I do it? Well, I'm going to start at A. I need to measure something that's over halfway. Doesn't have to be far, but I want to be sure that it's over. I don't want to cut it too close here. So I'll put it over there. That's definitely over halfway from A. Then I'm going to go to my compass tool. I assume that you have all familiarized yourself with GeoGebra as instructed. I'll go from the outside of the circle to the center and confirm by clicking again. Now I need to do the same size circle but centered at B. So I'm going to my compass tool again, same thing from C to A, but I don't confirm, it's floating. I'm going to move it around and center it at B. I'm just going to move myself up a little bit like so. That gives me 2 points here where these two circles intersect. GeoGebra automatically names the points. So in our case now it's D and E. Then I draw a line segment from D to E, and that is perfectly square and cuts the original line AB in half. Just a reminder, something that will become quite important in my opinion, we can hide the non-essential things. I still want to show them in any sort of test, but as the constructions get more complicated, sometimes I don't want to see everything all the time. When I'm going to print my answers, sure, I see them, I show and hide them, and they're a little grayed out, which makes the actual end result stand out a little better. So it's nice. Definitely a feature I use all the time. Okay, so perpendicular bisector. If you're watching this right now, maybe, or after the fact on a video, and you have not mastered the perpendicular bisector construction, stop and go and do that first. It is essential. All right. Now we are going to start with a given circle. Let's put the circle over here. Boom, circle. Our next goal, is to draw different polygons, different regular polygons inside the circle. so that the vertices of the polygon sit on the circle. We say we inscribe, inscribe a polygon onto the circle when the polygon sits inside the circle. Or I can refer to the circle being outside the polygon, but one thing at a time. For this next group of constructions, I'm going to start with a circle, and I'm going to put a polygon inside it so the vertices sit perfectly on the circle. Okay. In later problems, you could start with a polygon and then put a circle on. So that's sort of the other way around. Here we're going to start with a circle. The circle will be given, or you just draw a random circle. Now it's given. How do we put a polygon inside it? Now, we're not going to look at all kinds of polygons. Some are easier than others. We're going to start small with a triangle. Regular. Everything's regular. Remember what regular means. All sides are equal. All angles are equal. Perfectly the best structured polygon of that type. Okay, how do I do it? And again, same as before. This might not line up exactly with the labeling used in the book. It's fine. Make your own set of instructions, set of steps for how to do this. Triangle first. Okay. So the first thing, after I have my circle, I am going to draw a diameter line. Now, because of how GeoGebra constructs a circle, I already have a point on the circle. Otherwise, pick any point and just draw a line through the center. I'm going to use my through line tool. It's just called line, because I want it to go to the other side of the circle. That then gives me a point on maybe the bottom. Another point. I could use B as well, I understand. But I like this one. I like it at the bottom. Then I'm going to take my compass tool, and I'm going to draw a circle centered at C, which means I'm going to go, which means A is going to sit on the outside of the circle. Click on the outside, then the center. There's my circle, and I confirm it. This new circle intersects the original in 2 points. I will label that point and that point. D and E automatically labeled. B with D and E give me the vertices of my triangle. So I will just draw straight lines, segments, connecting those points, and there I have my triangle. To make it stand out more, I will maybe remove the other lines. I don't want to remove my circle that was given. And I can see there is my regular triangle inside this circle. But of course, I want to show it because that's my work when I submit this for a test or anything. Okay, so the first construction, construct a regular triangle inside the circle. That was the first one. Let's clear this up. And of course, the video, you can watch this over and over and over until you have the steps memorized and can do it yourself. Next up is a square. So let's start with a circle. I'm going to put it over here, maybe. Same circle. Circle is given. I want to draw a square, which automatically implies a regular quadrilateral inside the circle. Start with drawing a diameter. It could be any diameter, but I'll use the point that I have already so that it doesn't get too lonely. There's my diameter of the circle. This gives me another point at the bottom. So far everything's the same, but that's about it. Now I'm going to draw a perpendicular bisector to the line BC. Now, yes, I do know the halfway point is A, but I can't eyeball the perpendicular aspect of that line. I know it's going to go through A, but I can't just randomly draw it. It's not going to be perfect. So I need my perpendicular bisector construction, which means let's go from B. I want to go over halfway. I see halfway is there. So maybe let's go just a little bit, maybe like that. Then I'm going to go to my compass tool and I'm going to draw a circle centered at B. So outside of the circle to the center, there it is. Then the same size circle but centered at C. Outside of the circle, centered at B, floated over to my new position where I want it. It has to be the same circle size. That gives me my 2 points. Where those two circles intersect is just the perpendicular bisector construction. Nothing fancy. And I'll draw a line through those points E and F, observing that it does go through A, which I knew that was the halfway point. So it's a nice little verification there. Now maybe things are getting a little too busy on my page. I don't need the circles anymore. I don't need those points anymore. I needed a perpendicular bisector. So maybe I don't want to see those anymore. I now have new points where the perpendicular bisector intersects the circle. I've made a perpendicular diameter. Those are going to be the 4 points of my square. Now the square is sitting slightly rotated compared to how I would like it. But now that I realize that, we can rotate things a little bit. We'll do that in a second. Regardless, tilt your head. There's your square, perfectly inside the circle. Every vertex sits on the circle. Lovely. And of course, when I submit this, if this is what's asked, show all the things you hid from yourself for convenience, because that is the work that you have to show. Right. So hopefully so far so good. These things just take a little bit of practice, but arguably it's the most fun I've had so far. Just drawing some pictures. Let's just do this again, but create a square that's a little nicer. Let's suppose that's the circle that's given, right? I don't have to use that B point. I now know that if I use the very top point, my square is going to be a little angled. I'm going to use a point over there. No, not a circle. Get away from me. Undo. A point. I'll make my own point. That's going to be my point. And I'll draw my own diameter. I just have to start with a diameter. It doesn't have to be vertical. It doesn't have to be horizontal. It could be a little bit angled. Who cares? That then gives me a point on the other side of the circle through that diameter. I will now construct a perpendicular bisector to the line CD, just using the labels that they gave me. Doesn't matter what the labels are. Which means I'll start at C. I'm going to zoom out a touch. I'm going to start at C and then go a little over halfway. Well, I know A is halfway, so I'll go just a smidge over halfway. As long as I'm over, it's all good. Go to my compass tool. I'm going to draw a circle centered at C. So from E to C, click to confirm. I want the same size circle centered at the other side, D. So I'll again do from E to C, don't confirm, float it over to D. That gives me 2 points where those two circles intersect. Boom and boom. Then I draw a line through those points, and that is the perpendicular bisector, which I see also goes through A, which it kind of should. My diagram's getting a little full here. I don't want to see everything anymore. Maybe that looks a little less crowded. The perpendicular diameter then gives me two new points on my circle, original circle, which will be the other 2 points, other two vertices of my square. And I make line segments for the edges of the square. I can hide everything if I want to. That point. And there, I guess these two as well. I just do the hiding for convenience. It doesn't actually have to be gone. In fact, when I submit it, I don't want it gone. I want to show everything. Because if you just submit this, how do I know how you drew the square? I can't confirm that you did it in the way you should do it, so I show all my work. All right. So if you want your square to look more square-like, then just start with a different diameter line. Square. Hopefully all good so far. Once you get the hang of it, it's fun. I like it. I like it a lot. Let's start with the circle. Blah, circle. Circle is given. We've learned how to draw a regular triangle, an equilateral triangle. We learned how to draw a square. Next up is going to be a hexagon. A hexagon. Regular hexagon. Now, good news and bad news. Bad news is it's another shape I have to know how to do and master. Good news is it's very similar to the triangle. Very similar. So I'm going to start by almost drawing my triangle. So I'm going to make a diameter. I'll just use the top point for those guys. Vertical diameter is perfectly fine. That then gives me a bottom point on the circle, which will be the center for another circle. Use my compass tool, outside A, centered at C, confirm. So remember, of course, it was just a few minutes ago. You haven't even practiced it. But of course, remember that these two intersection points are the bottom vertices of my triangle. But instead, I'm not trying to draw a triangle. I'm trying to draw a hexagon. So I'm going to do the same thing that I just did, but center my circle up at B. Now I know these distances are exactly the same. BA and AC are the same because A is the center of the circle. So I don't have to copy the circle. I can just draw another one from A to the center B. Boom. But you can copy it if you want. This now gives me 4 points of intersection, those two circles on my original circle. Let's sort of gray out the circles that I used temporarily. And all these points are going to be the vertices of my hexagon. So I connect them with line segments, line segments, line segments, line segment, line segment, and I am done. Maybe I want to hide this guy too. Maybe just to look at it. Does it look regular? I'd say so, but that's hardly confirmation. I needed the construction to make absolutely sure. Without having a ruler and measuring the sides, without measuring the angles, just drawing circles and lines, I make it perfectly regular. Hexagon. All right. So far, given a circle, we can draw a equilateral triangle, a square, a regular hexagon. What's next? A regular octagon is next. Let's start with the circle. Circle is given. Boom. That's given. My goal next is to draw a regular octagon inside the circle with vertices perfectly on the circle. How do I do it? Well, I start by doing the same process I did for a square. Diameter, and this time I'm going to go with a vertical diameter because it looks nice at the end. Vertical diameter, though you can start with anything, right? It doesn't matter to me. What was the next step in drawing my square? Well, I have a point here at the bottom. My goal next in the process of making the square, I have to make a perpendicular diameter through the center, of course. And that is also going to be, in this case, the perpendicular bisector. So I go through my perpendicular bisector construction. Let's go from B, a little over halfway. Could be a lot, could be a little. I'm going to go a little smidgy. But it doesn't matter as long as you're over halfway. Then I'm going to go to my compass and draw a circle with a radius BD. So from the outside to the center, confirm it. Same circle, but centered at C. So from D to B, floated over to C. That then gives me 2 points where those circles intersect. And connecting those 2 points with a line will be my perpendicular diameter I needed for the square. Those give me 2 points on the circle. Let's hide some stuff. I don't want to see everything. Maybe it is a distraction. Maybe not. Let's hide it all. So, I don't need this D either, right? Get away from me, D. There we go. We have our only goal was to find the vertices, the corner points of the square. Now we're not going to draw the square, but so far the procedure is the same. We just don't actually finish the square because our goal is to draw an octagon. But the first part is the same. I am, however, going to draw one of the edges of the square. Just one. And then I'm going to work with that one a little bit more. What we're now going to do is a perpendicular bisector to this line segment BG. Same procedure for a perpendicular bisector. Let's center it at B. Let's go a little over halfway. Now I don't know exactly where halfway is. It might be somewhere over here. So I want to be safe and be sure I'm going over. I think let's go nice over like that. I know that's over for sure. Then I go to my compass tool. Circle centered at B with radius BI from the outside to the center, confirm. Same circle, but centered at the other end of the line segment. Same circle, outside I to center B, but floated over to G. That gives me a new point. Well, actually 2 points, right? This guy as well. That I can connect with a line segment. Same construction of the perpendicular bisector. Notice how it goes through A, the center of my original circle. I can use that as a check that it's probably okay. It's not a guarantee, but if it didn't go through A, then something is definitely wrong. So there I have KJ as a perpendicular bisector to BG. The only goal was to find where that KJ line intersects the circle. That was the only reason I did any of this. Now that I have the point that's called L, I will hide all the other things that were used to create that point. That's the only point I'm interested in. I actually don't care about K and J either. So to help me keep track of, nor I don't care about I either. Get away I. To help me keep track of what I have, if I see everything, it's hard. It's very confusing, potentially, to see what am I doing next and what have I done and where am I? There's so many lines. I don't know. I'm freaking out. Hide it all. Hide it and see what you have. Now, this L is a corner point of my octagon. The distance, let's draw some sides of the octagon already. I have a couple of sides already. I just need to do it all the way around. Now this side BL is the side of the octagon, so whatever the point is on the other side, it's going to be the same distance, the same length. So I'll use my compass tool, make a circle centered at B with length BL, and that gives me my point on the other side. Make my line segments for the sides of the octagon, and now I have the top half of the octagon. I don't necessarily need that guy anymore. Get away from me. I'm almost done. I just have to do the bottom half. But I know, for example, if I look at G, this side length GL is going to be the same side length from G to the bottom corner point, the bottom vertex of my octagon. So I'll go to my compass tool again and go from L to G, confirm, and that gives me the other corner point over here. Maybe I don't want that circle now, but I have almost finished my octagon. One more little quarter to do. Let's go from H down. HM is the side length of the octagon, so H to the bottom point is going to be the same length. So I'll go and make a circle with radius side length of the octagon centered at H. Just go all the way around and measure the points. Maybe I don't want to see that circle now. I just wanted the vertex that was missing. And there is my octagon without any distractions of the constructions, just so that I can see, okay, it looks okay, right? Now, if I want to submit this, I can show and see all my work that I did to get me there. And you see how, looking at the end result, it kind of looks impressive, I have to say. There's a lot happening. And of course, a lot to practice. Start the same way as a square. Then focus on one side of the square, bisect that. That gets you your corner point up here. And then just measure those distances all the way around. So submit this so I can see your work. Oh, I see the bisector there. Yeah, okay. I see the perpendicular diameter being constructed here. I see it. But if you don't show it, then I'll give you 1 for having an octagon. But I can't confirm how you did it, right? This is where all the marks go. The work, the steps, the process. Now it's getting fun, I think. So, what have we done? What have we done? We start with a circle today. We draw, inside the circle, we draw an equilateral triangle. We draw a square. We draw a regular hexagon. We draw a regular octagon. Now we're not going to go too crazy with this. Of course, we can draw any size polygon. Let's just do one more just to see how spicy it can get. And we'll go to a regular pentagon. That's going to be our last one. So there are 5 polygons that you have to draw inside a circle. Triangle, square, hexagon, octagon, pentagon. Just 5. You can count them on one hand. It's so easy. But it is up to you to practice, practice, practice until you have mastered it. What does mastery mean? It means you get a friend to wake you up in the middle of the night and ask you, here's a piece of paper, compass, straight edge, draw a regular octagon. After you slap them for waking you up, can you do it immediately? Or do you have to go look it up and think? No, you have to do it right away. Right away. I'm sure there is a way to draw a star, but it won't be perfectly inside the circle, right? I need um, another position, another circle, because the star isn't it's not a regular polygon. It doesn't have a rounded shape with all vertices sitting on the circle. The outside of the star maybe could sit on the circle, but what about the inside vertices? There are sort of 2 levels of vertices, and that gets complicated. I'm sure you can YouTube how to draw a star with a compass and a straight edge. I think that'll be a little bit too much for us. You'll see. This one's already pushing it a little bit. But the theme is we get an idea of the basics. We peek behind the curtain, and we're good. This pentagon is going to be a little peek behind the curtain. Explaining why this is the construction is not simple, so I can't really explain it here. But I'll try and go slow enough, and maybe we'll do it twice. We have the time. We'll do this one twice. Okay. First of all, start the same way as usual. Start with the diameter for my circle. Right. I'll just use the top point. Why not? Why not? Okay. Now that gives me a point at the bottom of the circle, the other end of the diameter. Great. I want to again draw a perpendicular diameter to this BC line. I can do that by drawing a perpendicular bisector to the line, because that bisector is going to go through A, so it'll be a diameter anyway. So I go from B maybe over halfway. Let's go over there. Then go to my compass tool, outside to center, like we've done many times now. Like I said, going into this class, you should have mastered this anyway. Then I want to copy the circle, but center it at C. So I'll do that. That, again, like always, gives me 2 points where those circles intersect, which I will connect with a through line because I want to see where they sit on the circle. They sit over here and over here. Actually, I don't care about this point. I'll leave it. It's fine. It is fine. So now I am done with those circles. I'm done with these points. I don't actually care about them. They served their purpose to give me the perpendicular diameter. Now, this is different. Pentagon's different. You could argue that, oh yeah, well, a hexagon has 6 sides, triangle has 3, 3 is half of 6, or 6 is double 3, so the constructions are similar, yes. Octagon, 8 sides, square 4, 8 is 4 times 2, similar construction, sure. Pentagon, 5, no, different. This is where the difference begins. So now I'm going to look at half of this horizontal diameter, the line segment AH. Only this little guy, this radius. And I'm going to bisect that. So, how do I do that? I forget everything else. AH is my line segment. So I'm going to go in centered at A. I want to go a little over halfway. Halfway sits around here somewhere. So I'm just going to make sure I go over halfway. That seems safe. Then I'm going to go to my compass tool. I'm going to draw a circle with radius AI, outside to center. There it is. Then I'm going to copy that circle and move it to the other side of my line segment, which is at point H. That gives me 2 points where those two circles intersect. It's the same perpendicular bisector construction. I'm just going to do a line segment here because I don't care where it extends to. And that gives me a point where the perpendicular bisector actually intersects, the halfway point between A and H. Now I need to regularly hide some stuff because it's going to get a little messy if I don't. And I will undoubtedly make a mistake. If I don't hide stuff on the way, this is going to get bad really fast. And looking at everything, I'm just going to miss what I'm supposed to be doing and get distracted. So I hide stuff as I do it. My goal was to get the halfway point between A and H. Now that I have that, the construction on the way isn't necessary anymore. I have that point. Okay. So now, this is where people get confused very quickly because I can't explain why. I understand it is confusing. This halfway point, L, or a quarter of the diameter, is going to be the center of a circle extending to B, the top point. So my compass tool takes the outside to the center. Okay. And it's still floating. I need to confirm it. There it is centered. That is done to give me a point where this circle intersects the horizontal diameter. So I get this point over here. M. Now I'm done with that circle. I don't need it anymore. Hide it so I don't get distracted. Okay. Technically, I don't need this point L either anymore. Oop, it's gone. I need this point M. Now I'm going to draw a circle, but not centered at M to B, but centered at B to M. So actually, let me not hide L, so I can see the sort of the process here. I found this point L, which is halfway on the radius. Then I go circle centered at L to B. Now I'm going to go circle centered at B to M. But when I use the compass tool, it's outside of the circle to the center. Okay? Confirm. That gives me a point where the circle intersects, this intersects the original circle, as well as on the other side. Point O. I'm done with the circle. Hide it. Hide M. Hide all of it. There we go. Just needed those guys. This is going to be some of the vertices of my pentagon. I need the bottom two vertices, right? I have 3 of them already. I need the bottom ones. How do I do that? Well, the side lengths are always the same. So if I look at BO, that is the side length. Same as what I did for the octagon. I just make a circle with radius that side length and follow it down and see where it intersects over here. So from B to O will give me a circle centered at O with that radius that I can follow down and see over here is my other side length that I can connect. That circle served its purpose. Let's hide it. See if you didn't hide it, How would you keep track of anything? I can't. I tried. I tried to do it without hiding anything, and whew, so easy to make a mistake. Understandably. We're almost there. We just need to do the same thing, but on the other side, N is the center. Measure a radius to B, follow it down, and see where it crosses my original circle. So I go to my compass tool. N is my center. So from the outside to N, confirm. And there we go. That gives us another point over here. Let's hide that circle. It served its purpose. And finish my pentagon. Isn't that nice? Isn't that nice? Peek behind the curtain. These things get complicated, and proving why this construction works. Whew, that is a spicy meatball that we can't really handle. But we can construct it. Look how pretty it is. So pretty. We should probably do that one again. Blank canvas. Let's do it again. So much fun. You decide how many times you need to do this until you have mastered it. Because you could say, well, the test is open book. Why would I have to master anything? If you don't, and you have to follow the instructions to draw a pentagon, it'll take you forever. And the test isn't designed with that kind of time. You will run out of time. Especially this one. If I can master it, you can master it. I have a terrible memory, so you can do it. All right, we start with a little vertical diameter. I like to position these the same way, so I'm starting with a vertical diameter, so it doesn't look rotated and confuse me. I'm going to have my pentagon sit nice and flat eventually. That gives me another point over here. Now I'm going to look for a perpendicular diameter to this line. I can get that with my perpendicular bisector construction. Let's go from B over halfway. Let's put it over there. Then I will draw my circle centered at B. And same size circle centered at C. Giving me my 2 points that I can use to make a perpendicular diameter. I've constructed it. Let's just label the 2 points where this diameter intersects a circle. I don't need all the construction materials anymore. They have served their purpose, and their purpose was to make a perpendicular diameter. So, what is next? I have to make a perpendicular bisector of the radius line, and I'll pick this horizontal one. Of course, you can pick another one too, but I try and always do the same thing. So I always pick the right horizontal radius. Perpendicular bisector. From A, I need to go over halfway. That seems safe. Just make sure you're over halfway or it won't work. Then I'll draw a circle centered at A with that radius. Copy it to the other side of the line segment. That gives me 2 points. Whoop, my phone just fell off the table. That's nice. Hopefully it's still good. Line segment as the perpendicular bisector. That gives me a point. Boom. That was the only goal here, to find the halfway point between A and H. I now have that halfway point, which means all the construction material that was used is irrelevant. Irrelevant. I only wanted that point L. But how else would I do it? I can't measure anything. I have no ruler with a marking. My tools are drawing a straight line, drawing a circle. That's all I can do. Yet we're able to do all these things. It's quite impressive, really. There were no rulers when they developed geometry. That came later. Now, the key thing here that people very often mess up, is I like to think of it as direction. I'm going to go from L to B, B to a point down here, and then that point to the circle. It's like a zigzag pattern. L to B, down to here, up to the circle. Okay, so my first circle is going to go L to B, centered at L, radius to B. Boom. That gives me my point over here. Once I have that point, that circle is gone. We actually have the benefit. Using an application like this allows me to selectively see what I want to see. It's actually very nice. If I were to do this on paper, I would have to always look at all of these things. And it's much more difficult. I can't erase them. Not really. The benefit of doing it electronically is I can actually erase them and bring them back whenever I feel like it. It's beautiful. I think I'm always doing it like this from now on. I have this point M. You want this point L served its purpose. It's done. I don't need it anymore. But I'll show it. I want the path L to B to M to circle, which means I'm now drawing a circle B to M. Now, I understand that the distance BL or LB looks very similar to BM. It is not the same. It is off by a little bit. It is not the same. If you measure them the same, your pentagon will not look right. So now I'm going to go outside the circle, centered at B, done. That gives me my point on the circle. See, L to B to M to N. Now I don't think of the names of the points because that could change. Just the zigzag pattern. Whatever works for you, honestly, whatever works for you. All these points are done now. Hey, go away. M. M doesn't want to go away. Okay, fine. Stay there then. I don't care. I have a side of my pentagon. I need the other side. But that is just the radius of the circle that I can measure to the other side. So once I have one side, it's all good times. That gives me other side of the circle. Boom. I could have done it with the circle that I already had when I drew B to M, but whatever. It is gone. I don't think I can gray out both of them. No, I can. Nice. Then B to O, other side of the pentagon. Now I need to go down to the bottom two vertices. So I'm just going to use some circles again. Let's go O to B. That gives me, I don't do too much at once, one point at a time. Because if I see too many circles and things, I get confused. That gives me another side of the pentagon. Then I'll do the same thing, but on the other side. And that'll give me my last vertex of the pentagon. Maybe I want to hide that circle. Maybe I don't. It's up to you. But in the end, you have to show absolutely everything. Boom. Boom. Pentagon. Work. Look how much we did. It's awesome. Awesome. Wish we could do more, but I think we get the point. Get it? Point and line? No? Okay. All right. Those are our constructions. Now, it's not all of it, but that's our next step. Given a circle, can you draw an equilateral triangle, a square, a regular hexagon, a regular octagon, a regular pentagon? Only those 5. Tomorrow, we will venture forth into the problems in this case, I don't want you to struggle with the problems on your own. Some of it maybe, and you're welcome to, but I think it has benefit if we sort of talk about the problems, and it'll make things a little less overwhelming. You have still the challenge of memorizing the steps, of practicing the drawing. That's still the challenge. I'm not going to give you anything that you haven't seen before in a test, so it's worth it in this case, for this topic, to sort of go through that and talk through that. The other thing that we want to do is, given a regular polygon, so let's just notice what we've done here, right? We have today started with a circle. The circle is given, draw the polygon inside it. I want to do the other direction. Given a polygon, draw the circle outside it and maybe inside it. It's different procedure. So we'll wrap it up with some variations tomorrow, and that'll give you a good picture of these constructions. Any questions or thoughts that you would like to share at this time? I don't know when this video will be uploaded, and I'll tell you why. I don't know why this is, but I've proved it. It's a fact that if I upload to YouTube, my entire internet connection shuts down. I can't do anything on the internet while that upload is happening. I don't know why. I've tested it. Everything shuts down. So I have to time the upload correctly for a time when I know I won't have to check email, I don't have to do anything else, which is usually at night when I go to bed. It's a little bit difficult in the day, which is why the uploads are a little bit later, but that's not really a big deal, because if you go to our YouTube channel, there's always a backup of the live video. You don't need this one to be uploaded. The live ones don't always work that great, but you can technically watch it even now. You can watch it while it's being recorded. YouTube makes a backup of the live video. There's a live section or a live tab or something. So you don't have to wait for the upload. It is already there. It's just I don't want to include those in our playlist because sometimes that doesn't work perfectly. So I double check the video, double check the sound, and then upload something that I know works. But it is already there, so that's not a concern. All right. Any other thoughts? I know this was a lot of fun. I really looked forward to this section. It's very enjoyable, especially doing it electronically. I'm doing it this way from now on. No more paper for me. Save the trees. Do it this way because it's just so nice. So nice. Anyway, it's up to you to practice, practice, so that you are efficient when it comes to the test. All right, I will stop my rambling and see some of you maybe tomorrow. Right, until then.